the theory of geometry as the foundation of existence. In this discussion, Professor Camps explored a groundbreaking theory that places geometry as the foundational principle of the universe, arguing that geometry preceded energy and even the Big Bang itself. This theory suggests that geometry is not merely a mathematical construct, but a pre-existing structural framework that governs everything in existence. It proposes that geometry serves a purposeful function in facilitating the efficient distribution of energy and, by extension, the organization of matter and the laws of nature. Let's break down the key points, supporting arguments, and conclusions. 1. Geometry preceding energy and the Big Bang. The fundamental argument. The central premise of this theory is that geometry must have existed before energy because energy itself is composed of geometrical structures at the subatomic level. Without geometry to organize and structure energy, energy cannot manifest or take form. Therefore, geometry is not a product of energy, but rather its structural prerequisite. Energy and geometry in subatomic particles. It was established that energy, in its most fundamental state, as in quantum fluctuations in a vacuum, manifests through geometrical patterns. Quantum fluctuations produce particles that decay instantly, but these particles require geometrical structures to emerge, even momentarily. This shows that geometry is embedded within energy at the most basic level of existence, and thus, geometry had to precede energy in the timeline of the universe. Geometry and the Big Bang. The Big Bang is traditionally seen as the moment energy and matter began to take shape. However, if geometry governs how energy manifests, then geometry must have existed before the Big Bang. The argument follows that the Big Bang didn't simply bring about energy, it required geometry as a foundation for energy to unfold and matter to emerge. 2. The purpose of geometry, efficiency and energy distribution. Geometry as the organizer of energy. Geometry serves a vital purpose in the universe, to facilitate the efficient distribution of energy. From the smallest systems, like atoms and molecules, to the largest systems, like galaxies and cosmic structures, geometry shapes the flow and transformation of energy. This efficiency can be seen in how energy behaves and interacts with matter, ensuring optimal structures and minimal waste. Examples of geometrical efficiency. The structure of natural systems, from the branches of trees to neural networks in the brain, to the spiral shape of galaxies, follows a geometrical pattern that maximizes energy distribution, maintaining the order and efficiency of these systems. The laws of thermodynamics, especially energy conservation and entropy, reflect this geometrical order, suggesting a purposeful design behind the universe's architecture.